Hi students, today we are going to see discrete Fourier transform. So we are going to see the formula for discrete Fourier transform and then how to solve the problems using your discrete Fourier transform. So discrete Fourier transform. So here if you take the Fourier transform of the DT signals, you'll be getting your discrete time Fourier transform. So in this discrete time Fourier transform, the omega frequency component omega will be a continuous one. So that we cannot process in the digital system here. So to convert DTFT to DFT, the continuous omega will be sampled at an equal intervals of time to obtain your DFT, right? So this discrete Fourier transform is defined, endpoint discrete Fourier transform is defined as summation k equal to summation x of k is equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi k n divided by n for k equal to 0, 1, 2 till you n minus 1. Again, the inverse discrete Fourier transform IDFT is defined as x of n is equal to 1 by n summation k equal to 0 to n minus 1 x of k e power j 2 pi kn divided by n, where n is equal to 0, 1, 2 till n minus 1. So now we'll start solving this problem. So before start solving your problem, here the way you're going to handle your calculator is going to fetch you the marks here, right? So keep it in mind, the calculator should be in radian mode, and then the pi value should be pressed as shift exp. So directly you have to press, and since your calculator should be in radian mode, so before the button before that of your on button, you'll be having your mode. If you press 4 times, you'll be getting your degree, radiant and gradient. So just choose your radiant mode, and then again you have to have your calculator in your complex mode. So if you press your mode in a once, you'll be getting your complex and compound. So you choose your complex. So before start doing your DFT problem, so before start doing your problem, you just take your calculator, keep your calculator in radiance mode as well as in complex mode. So this is very important. Right, so calculate your 4-point DFT of a causal sequence given by x of n is equal to 1 by 3 for 0 less than or equal to n less than or equal to 2 and 0 elsewhere. So I hope you know this type of representation is called as a functional representation, and draw its magnitude and phase spectrum. We saw that the frequency spectrum which we obtained is nothing but the combination of your magnitude and then phase spectrum. It's going to be a complex signal. So once you just got your problem, you have to get you have to find the n value and you have to get your x of n. So this is going to be the first and foremost step. So here they have given in a problem, they have given it as a 4-point, compute 4-point DFT. So your n is going to be 4 and your x of n is going to be, so since if it is a 4-point, your x of n input sequence should have 4 samples here. So for 0 less than or equal to n less than or equal to 2, it means the n value lies in between 0, 1 and for these three values, the value is going to be 1 by 3 and 0 elsewhere, but you have to get 4 values. So I'll be getting my x of n as 1 by 3, 1 by 3, 1 by 3 and then 0. Then wherever necessary, you have to write your formulas here. So that's going to be a good practice, which is going to get you the marks here, right? So n point DFT is given by x of k equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi k n divided by n for k equal to 0, 1, 2 till it's going to be n minus 1. So therefore, since we have to calculate your 4-point DFT. So 4-point DFT, so your n will be here, the n will be replaced by 4. So where and all I have n, it will be replaced by 4. So this n minus 1 is replaced by 3 and this capital N is replaced by 4. So x of k equal to summation n equal to 0 to 3 x of n e power minus j 2 pi k n divided by 4. And k equal to 0 to n minus 1, that is 0 to 4 minus 1 is going to be 3. So we have to substitute your k value as 0, 1, 2, 3 to get your x of 0, x of like for k equal to 0, so where and all I have k in this formula, I'll be replacing it by 0. That's it. So x of 0 equal to summation n equal to 0 to 3, x of n e power minus j pi. This k will be replaced by 0, n divided by, and you know it very well, e power 0, anything into 0 is 0, e power 0 is going to be 1. So it's going to be summation n equal to 0 to 3 x of n as e power 0 is going to be 1. Now I have to expand the summation by replacing my n value as 0, 1, 2 and 3. So I'll be getting it out as x of 0 plus x of 1 plus x of 2 plus x of 3. And I'll substitute the value of x of 1, x of 0, x of 1, 2 and 3 as 1 by 3 plus 1 by 3 plus 1 by 3 plus 0. So your x of 0 is going to be 1. Similarly, by substituting your k value as 1, I'll be getting a formula wherever I have k, replace k as 1. So x of 1 equal to summation n equal to 0 to 3, x of n e power minus j pi 1 into n. Now what happens is nothing but I can write this one as e power minus j pi n by 2. So try to arrive the final equation even if you're going to have one or more two steps extra. So that will fetch you the marks here without doing any mistakes here. Now I just expand the summation by substituting a value of n as 0, 1, 2 and 3. So wherever I have n, I'll be replacing your n as 0, 1, 2, 3. I have two n's here, x of n e power minus j pi n by 2. So I'll be substituting your n value as 0, 1, 2 and 3. So now I can e power 0 is 1. So x of 0 plus x of 1 into j pi by 2. Here it is 2 and 2 get cancelled. So e power minus j pi. And here it is 3 pi by 2. So you know it very well. E power minus x is equal to cos x minus j sin x. That you know it very well. So it is e power minus j pi by 2. I can write it out as cos pi by 2 minus j sin pi by 2. And here this e power minus j pi, I can write it as cos pi minus j sin pi. And this is going to be 0. I'm just making it out as 0. So use your calculator, find the value of cos pi by 2. Here what you have to do is you don't forget to put your bracket. So that is type it as cos open bracket pi divided by 2 close bracket. Suppose if you are not going to use your bracket, simply if you are going to type as cos pi by 2, what it will do now, it will give you the cos pi value and then that value will be divided by 2. So that is the difference between putting your bracket. So don't forget your cos open bracket pi by 2 close bracket. So this value will be 0 and sin pi by 2 value will be 1. So it's going to be minus j. So cos pi is minus 1 and sin pi is going to be 0. Okay. So now what happens? 1 by 3. This is plus 1 by 3 into minus j is going to be minus j 1 by 3 and this is going to be minus 1 by 3. So this 1 by 3 and minus 1 by 3 will get cancels with each other and then your x of 1 is going to be minus j1 by 3. So I got my x of 1. Similarly, I'll be substituting my k value as 2. So if I replace the k as 2 here, I'll be getting this one. So after cancelling this 2 and 2, I'll be getting e power minus j pi. Now I have to expand this one by substituting the as a summation by substituting your n value as 0, 1, 2, 3 in this one. So after this one, I'll be getting x of 0 e power minus pi j, then 1, 2, 3, and then x of 0 into e power 0 is 1. So x of 1 into e power minus j pi, x of e power x of 2 into e power minus j 2 pi plus x of 3 e power minus j 3 pi. Now this e power minus j pi can be written as cos pi minus j sin pi, and this e power minus j 2 pi can be written as cos 2 pi minus j sin 2 pi. Then cos pi value is going to be minus 1 and sin pi is going to be 0, cos 2 pi is going to be 1 and sin 2 pi is going to be 0. Now here what happens is 1 by 3 minus 1 by 3 plus 1 by 3. So your net result will be your x of 2 is going to be 1 by 3. So the last value will be obtained by substituting your k value is equal to 0. So now I'll substitute your k as 0, k as 3 here. So x of 3 equal to summation n equal to 0 to 3 x of n e power minus j by 3n by 2. So again what happens, I'll be expanding the summation substituting a value as n equal to 0, 1, 2, 3 here. Then I'll be writing my e power minus xx cos x minus j sin x here. And then cos 3 pi by 2. Here don't forget to put your bracket cos open bracket 3 pi divided by 2 close bracket. So the value is going to be 0. And normally the students will do a mistake here. Sine 3 pi by 2 is going to be minus 1. So what the students will do now, simply they'll put it as minus j. So here what happened, this minus 1 into minus is going to be plus. So here normally the students will have the tendency to do the mistakes here. So once for the trigonometric functions, if you have your sign as negative, you should be very careful while substituting the values here. So again, cos 3 pi is minus 1, sin 3 pi is going to be 0 again. So it's going to be 1 by 3 plus 1 by 3j and minus 1 by 3. So your x of 3 is going to be minus j 1 by 3. So I conclude that your x of k equal to 1 comma minus j 1 by 3 comma 1 by 3 comma j 1 by 3. Here they ask you to calculate magnitude and then phase spectrum, right? So to calculate your magnitude and phase spectrum, you have to convert this rectangular coordinates into polar coordinate, right? So rectangular coordinate to polar coordinate. So how to convert this rectangular coordinate into polar coordinates? Take your calculator now. After taking your calculator, you just this one for this value, I'll tell you how to calculate. Here it is minus j 1 by 3. So that is nothing but your real part is going to be 0. So type 0 minus I. So you'll be having a button ENG in your calculator. So if you press that ENG button, you'll and I will be displayed. So I into 0.33 equal to, press equal to. Now shift plus. So you just see that shift plus. So above that plus, you'll have your polar off, right? So shift plus, if you press and you press your equal to, you'll get your value as 1 by 3. And shift equal to, you'll be having minus 1.57. So since you kept your calculator in radian mode, you're getting your answers in your radian. Suppose if you're keeping your calculated in your degree mode, you will be getting your degree value in terms of degree as minus 90 degree, right? Suppose if you keep your calculator in degree mode, you have to substitute your pi value as 90 degree. So since we are keeping it in standard radian mode, I'll be making use of pi value directly. That is shift exp. For our ease, I'll be using this one, right? So similarly, here what happens, this plus j1 by 3, 0 plus j1 by 3. After typing it out, press equal, then shift plus will get you, equal to will get you the polar. So it will be 1 by 3 and shift equal to, you will get your radiant. So for this one, you have to get your diagram here. So in this magnitude spectrum, always your x-axis will be okay, y-axis will be your magnitude value. Right, so here the k value is going to be 4. So 0, 1, 2, 3, and then your x of k, the value ranges from 1. Maximum value is 1. So I took as a 0.5 and 1. So when k equal to 0, the value is 1. When k equal to 1, it's 1 by 0.33. For 2 and for 3, it's going to be 0.33. So this is the way you have to draw your magnitude spectrum, and as well as your phase spectrum. Again, your k is going to be, your x-axis is going to be k and y-axis is going to be your angle. Since you have your negative as well as your positive angle, I took the values here. So when k equal to 0, the value is 0. When k equal to 1, it is minus 1.57. When k equal to 2, it's 0. And when k equal to 3, it's going to be 1.57. So this is how to draw your magnitude and phase spectrum. Okay, so since they might ask it in 8 marks, so it's better to verify your answers. To verify your answers, I'll be telling you the shortcut method for calculating your 4-point DFT. So in matrix method, I can calculate the 4-point DFT. So your DFT of the signal is equal to this 4 cos 4 matrix is common for all. So I have to by heart it out, right? So this column is going to be 1 and then the first row is going to be 1, first column is going to be 1. And here it's minus j minus 1 j and minus 1 1 minus 1 and this reverse of it. So j minus 1 minus j. You just bygo this one, and this is going to be the input sequence. So if I substitute the values here, so again to get your values, take your entire row, multiply with this column. So entire second row, multiply column, third row, fourth row. So multiply with this column here, you'll be getting your answers. So your x of k will be 1 minus 1 by 3j, 1 by 3, and then plus 1 by 3j. You'll be able to get your thing. So I can verify my answers here. Suppose if any mistakes, if you have any mismatch, that particular k value can be verified once again. So to make sure that your answer is right. So similarly, I'll tell you how to compute a rate point. Same procedure. One more thing I have to add here. So compute 8-point DFT of the sequence x of n equal to minus 1 by minus 1 to 2, 2 minus 1, right? So first part I told from the equation, from the question you have to take two parameters. First one is you have to find the n value. Second one is you have to get your x of n, right? So here your n value is 8 because he asked you to compute 8-point DFT. And here x of n, you have only 5 values, but your n is 8. So your x of n should have 8 values. So to compensate, I have added 3 zeros here. That's your zero padding. Right, so with this one, I'll be writing your formulas here for n-point DFT. And then for 8-point DFT, I replace my n as 8 here, right? So this n minus 1 becomes 7. And here I have made it as 8. Your k value is from 0 to 7. So now I'll be substituting my k value as 0, 1, 2, 3, 4, 5, 6, 7 to get this. So x of k equal to 0. If k equal to 0, x of 0 equal to replace k by 0 here, right? So e power 0 is going to be 1. So I can write this one, expand this summation by substituting your n value as 0 to 7, substitute your values and get your answers here, right? So simple as that. So for k equal to 1, so replace your k as 1 in the equation. After that, expand the summation here. So by substituting your n value as 0 to 7, then what happens here is I'll be having this one e power 0 is 1, and then I have all this value here by replacing my n as 0 to 7, and then this exponential value will be written in terms of your trigonometrics. The e power minus x is nothing but cos x minus j sin x of all these things, and the last three value is going to be 0. And then so cos pi by 4 is going to be 0.707, sin pi by 4 is minus j 0.707. So similarly, after finding all the values here, you just find the values here. Here this minus 1 and plus 1 will get cancels with each other. Again 1.414 minus 1.414 get cancels with each other. And then so the sum of all these three j's is nothing but x of 1, which is equal to minus 4.828 j. Similarly, by substituting my k equal to 2, I'll be getting this one, and then expand the summation by substituting your value of n as 0 to 7. Then convert your exponential term into a trigonometric terms, and with a calculator get the values of each, and then you just try to solve this one. So this 2j minus 2j will get cancels with each other, and then your x of 2 is going to be minus 4. Similarly, I'll be substituting my k value as 3 in the equation, then expand my summation by substituting your n value as 0 to 7. Then the exponential term should be expanded with the terms of your in terms of your trigonometric functions, and then find out the values here, and then you just solve this one. So here minus 1 plus 1 get cancels here, minus 1.414 plus 1.414 get cancels with each other. Then left out terms will be minus 0.828 g. Similarly, substitute your k value as 4 and then get the values here. If you substitute the same way, I'll be getting the x of 4 as minus 4. So similarly, k equal to 5. Substitute in the equation, expand your summation, substitute your trigonometric values in terms of, that is your exponential value in terms of your trigonometric, get your x of 5. Similarly, substitute your k equal to 6, or x of 6 will be your minus 4, and substitute your k equal to 7, or x of 7 is going to be your J 4.828. So here, while solving your 8-point DFT, you should be very careful here, because everything is going to be only addition and multiplication, but you have more number of terms. So you should be, while doing this problem, your concentration should be at this problem alone. So if even if you deviate for 5 seconds, then definitely there is a possibility of making mistakes here. So finally, you have to get your answers as x of k equal to that 8 answers. I'll be. So here you have to note down one thing: your x of 0 and then your x of 4 is going to be your unique value, right? So remaining thing x1, x2, and x3. So this value will be your, you'll be getting this value, and then x5, x6, x7 will be the complex conjugate of the first three values. See here, this is minus point j 0.828. This is plus j 0.828. So this is minus 4. Here it is minus 4 because you don't have your imaginary part. So here minus j 4.828. Here it is plus 4.88. So complex conjugate is nothing but there will not be any changes in your real part. Only the sign get changed in your imaginary part. So if you have any doubts, so you can contact me.